Hi, my name is Alex Powers, and I'm an engineer on the enterprise team for visionOS. It's great to be back at WWDC. Last year, we introduced the first set of enterprise APIs for visionOS. Since then, we've been working hard to bring you even more enterprise capabilities. Before exploring the new features, let me review the fundamental requirements for the enterprise APIs. Because they offer broad utility and deeper device access, accessing these APIs requires a managed entitlement along with a license file tied to your developer account. And designed for proprietary in-house apps developed by your organization for your employees or for custom apps you build for another business to distribute internally. With those considerations in mind, I'm excited to take you through the new enterprise APIs and some major improvements to the existing APIs. I'll start with changes that will streamline your development and make it easier for you to access enterprise capabilities. Next, I'll show you a way to enhance the user experience by providing new ways to interact with Windows, share content with people nearby, and protect sensitive information. And finally, I'll explore new capabilities to visualize your environment. Let me begin by showing you some ways we're making it easier to access enterprise capabilities and streamline your development. Starting with wider API access. We've made some changes this year to give you wider access to several APIs we introduced last year. We previously introduced the ability for an app to access external video from USB video class devices through the Vision Pro developer strap. The API allows your app to leverage UVC-compatible webcams for enhanced video conferencing, specialized imaging devices for remote diagnostics, or industrial inspection cameras for quality control. We've also made access to Neural Engine available for advanced on-device machine learning. I'm happy to say that with the latest visionOS, these APIs are now available for all developers. You'll be able to access UVC video and Neural Engine without an enterprise license or an entitlement. Last year, we introduced object tracking for visionOS, enabling powerful experiences where your app can recognize and track specific real-world objects. This year, we're adding the ability to train directly from the command line. This means you can now automate the model training process, integrate it into your existing pipelines, and manage your object tracking assets more efficiently, all without needing to manually use the CreateML app for each individual object. This tool gives you all the same controls as the CreateML app. I hope this will unlock new workflows and make iterating on your object tracking features faster and more scalable. We're also making enterprise license management simpler. You can now access your license files directly within your Apple developer account. Renewals are automatically pushed to your apps over the air. And we've created the Vision Entitlement Services framework. This framework makes it straightforward to check if your application is properly licensed and approved for specific features. Using Vision Entitlement Services, you can determine if your app can access specific enterprise API like main camera access, see your license status and its expiration date, and for apps using the Increased Performance Headroom entitlement, you can verify this mode before intensive tasks to ensure the best performance. As an example, let me show you how you would determine if your app is configured properly to access the main camera. First, import the framework. Then, use the Shared Enterprise License Details singleton to first confirm that the license is valid, and then confirm that the license is approved for main camera access. So that's how the latest visionOS expands API access and makes developing models and managing your enterprise apps easier. Now let me walk through some new ways for enhancing user experiences by building more intuitive, collaborative, and secure spatial applications. First, we're introducing a way to make window interactions in spatial environments more natural, especially when moving while wearing Vision Pro. We call it Window Follow Mode. When enabled, it ensures content remains accessible and relative to your position. To enable this behavior, you need the Window Body Follow entitlement. This entitlement is requested and managed as a licensed entitlement. Once the entitlement is granted and included in your app, this behavior will be enabled for any window on the device in all applications. Standard windows in visionOS remain fixed in space where you place them. But imagine you have a dashboard, a set of instructions, or reference material that you need to glance at frequently while performing a task that requires you to move. Window Follow Mode allows you to choose a window and have it move with you as you move from place to place. Let's see Window Follow Mode in action. Here I am, focused on a project at my workbench. At the same time, my manipulator arm is executing a task. I want to monitor the manipulator's status, but without constantly interrupting my main task. To enable Window Follow Mode for the status window, I click and hold the Window Close control. I choose Start Follow Mode. And there we go. The status window will follow me as I move back to my work area. So that's Window Follow Mode, one great way to enhance your user experience. But spatial computing is truly at its best when enabling shared, collaborative experiences. And that's precisely what shared coordinate spaces enable. This feature allows people who are physically together to share their spatial experiences with each other. Everyone can naturally interact with and discuss the app's content as if it were physically present. We provide high-level APIs using SharePlay that automatically handle the discovery, connection, and session management for shared coordinate spaces. We have a whole session on this called Share visionOS Experiences with Nearby People. While SharePlay offers fantastic ease of use out of the box, we understand that some scenarios demand more control. You might need to integrate with your own custom networking infrastructure, or maybe your enterprise requirements mean you have to handle device communication directly. For these use cases, we're introducing a new ARKit API for establishing shared coordinate spaces specifically for enterprise customers. It's called the Shared Coordinate Space Provider. This API allows multiple participants to align their coordinate systems. This is achieved by exchanging specific ARKit-generated data over your chosen local network transport. Each participant continuously shares this data with the others. This continuous sharing creates a common coordinate system, enabling shared world anchors to appear consistently for everyone. With that, let me run through how you would use this API to build a custom shared experience. Using Shared Coordinate Space Provider is straightforward if you worked with ARKit data providers before. Similar to world tracking or hand tracking, you instantiate it and run it on your active ARKit session. Once running, the Shared Coordinate Space Provider generates the necessary alignment information encapsulated in coordinate space data objects. You retrieve this data using a pull-based API, the provider's next coordinate space data function. My application is responsible for transmitting this coordinate space data to the other participants to establish a shared coordinate space. This gives you full control. You can use any networking layer that you want. Conversely, when your app receives coordinate space data from another participant over the network, you provide it to the local shared coordinate space provider by calling its push method. Each piece of incoming data is tagged with the sender's unique participant ID. Finally, the provider helps you manage the session lifecycle. It offers an event updates async sequence to inform you about important changes, such as when a participant has left the shared space. Let me walk through an example of how this works in code. I start by creating a shared coordinate space provider and running it on my ARKit session. When data arrives from another participant on my network, I update the local provider's understanding using push data. To get the data my device needs to share, I call the next coordinate space data function. This gives me the coordinate space data object representing my local state, ready to be broadcast over my network. Finally, this logic forms the heart of my custom shared space management, bridging my networking layer with ARKit's coordinate alignment. So that's ARKit's Shared Coordinate API for enterprise developers, a great way to add collaboration to in-house apps. My final user experience enhancement is all about data privacy and security. Many enterprise apps handle sensitive information, financial data, patient records, proprietary designs, or confidential communications. And while incredibly useful, capabilities such as SharePlay, screen captures and recordings, or even screen mirroring can inadvertently expose this sensitive data. So today, there's a new API that gives you control over what can get captured and shared with others. And it's the new Content Capture Protected View modifier for SwiftUI. It's supported in apps with the protected content entitlement. You simply add it to any user interface element or even entire RealityKit scenes. When content is marked as protected, the system will automatically obscure it in any screen captures, recordings, mirrored or shared views. However, the content remains perfectly visible to the user wearing the device. Here's an example of a common enterprise use case. I have an app that serves as a central repository for my company documents, accessible to all employees. However, certain documents within this system contain sensitive information and shouldn't be shared widely. I'm sharing these documents with my team in the other office. Here, the team can see our meeting notes and the plan for next year. Both of these documents are visible to me and shared with the team. Here, you can see the quarterly report has a lock icon. This report shouldn't be shared, and so my team can't see it on the remote display. Now that you've seen protected content in action, let's see how to implement it. In this example, I have a document view that contains a child view that I've called Sensitive Data View. It has information that needs to be seen only on Vision Pro. To protect it, I append the view modifier, Content Capture Protected, and I'm done. The system will now obscure the feed whenever any attempt is made to share this content. You can also integrate this content protection with authentication flows like Optic ID or corporate single sign-on. So that's how to protect app 2D and 3D content. It can be protected with the same simple modifier. So those features enhance the experience within the digital space. Now I'll focus on some features designed to help visualize the environment and bridge the physical and digital worlds. First, we're expanding camera access on Vision Pro. Vision Pro uses its sophisticated camera system to capture the wearer's environment, with the forward cameras providing the pass-through experience. Last year, we shipped an API to provide access to the device's left main camera video feed. And this year, we've expanded the API to provide direct access to the individual left or right cameras, or access both for stereo processing and analysis. If you're already familiar, it's the Camera Frame Provider API in ARKit. And now, camera feed support is available in both the immersive space and shared space environments, allowing your app to function alongside other apps and windows. So that's how the latest visionOS makes camera access even more flexible. Now let me show you a new way to visualize details in your surroundings. Professionals often need to monitor specific details in their work area. For example, technicians need to read small gauges on complex machinery, or inspectors might need to examine components in poorly lit areas. To address this, We're introducing a powerful new feature that allows people wearing Vision Pro to select a specific area in their real-world view and provide a dedicated video feed of that area in its own window. This feed can be magnified or enhanced, making critical details clear. There's a new SwiftUI view in VisionKit called Camera Region View. You simply position this window visually over the area you want to enhance. Then, the Camera Region View uses its own position to provide the appropriate region and space for the virtual camera. If you require more fine-grained control, you can use the new Camera Region Provider API in ARKit. This gives you direct access and is useful if you're already using ARKit, familiar with anchors, or have more specific UI needs. Here's a demo of how it works using an example status app that I've created. Here, you can see that I'm back with my project. This time, I'd like to monitor the pressure in the system while I work. I'll open the inspector window of my status app and place it in front of the gauge. As you can see, the video feed of the gauge has appeared in my status app. Now, I can return to work and keep an eye on the pressure while I work. Now let me show you how I added a camera region to my app in just a few lines of code using SwiftUI and the VisionKit API. First, I import VisionKit. I define a standard SwiftUI view. I've called it Inspector View. This will contain the camera region. The core of this view is Camera Region View. I'm initializing it with the isContrast and Vibrancy Enhancement enabled parameter, passing true to enable stabilization with contrast and vibrancy enhancement. As I mentioned, this view needs to live in its own window because it uses the window's position to determine what part of the pass-through is processed. For that, let's look at the abstract. Here's my abstract. I have a main window group for my primary app content. I'll make a second window group for the inspector view. That's enough to add a camera region to my app. But for more complex applications, Camera Region View supports a closure. So I'm going to change my code to use this closure to analyze the camera images, and later I may add a feature to save the images to a file. I'll modify the Camera Region View to accept a closure, allowing me to process each camera frame as it arrives. First, I add my camera feed delivery class that I've made to capture camera frames and deliver them to the rest of my app. My closure will use the pixel buffer from the camera region view. Here, I'll check for errors and pass the pixel buffer to my camera feed delivery class. My closure returns nil, which indicates that I've not modified the pixel buffer. I could also use this closure for custom processing. If I modify the pixel buffer and return it, then the camera region view would render the adjusted camera image. So with just a few lines of code, I've added camera regions to my app. In my example, I enabled contrast and vibrancy enhancement, but the camera region APIs provides two built-in processing capabilities. First is image stabilization. This ensures that content remains anchored and stable during natural head movements. And second is contrast and vibrancy enhancement, which includes stabilization and optimizes for brightness and color representation. Now let's look at ARKit's API for camera regions. Perhaps your application would like a camera region associated with a particular 3D object, or you'd like to place a camera region after recognizing a specific object in the environment. If your application needs this level of fine-grained control over anchors and 3D objects, this API provides the low-level primitives, and you'll need to define the anchors. In ARKit, your anchor defines a virtual window into the real world by specifying its transform and physical size in meters. This window defines an area where you'll see the direct, stabilized view of the pass-through camera feed. You can think of it like placing a virtual camera right there in your physical space. This virtual camera doesn't need to be attached to a visionOS window. It can produce a feed of any location within view of Vision Pro's cameras. Now let's take a closer look at the API. ARKit offers a new type of data provider called the Camera Region Provider. Integrating camera regions follows a familiar ARKit pattern. I start by running a data provider on my ARKit session, just like I would for other ARKit features. With the provider up and running, my next step is to pinpoint the area for a camera region. I do this by creating a camera region anchor and adding it to my provider. Think of these anchors as specifying the exact regions in the real world that I want for the virtual camera. As ARKit runs, the provider sends updates to these anchors. Each update comes with a new pixel buffer. This buffer contains the stabilized view for that specific spatial region. So let's dive into how I create one of these anchors. Creating a camera region anchor is straightforward. I define its position and orientation in the world using a standard 6-degree of freedom transform. Then, I specify its physical size, its width and height in meters. Together, these parameters define the real-world window for the camera region. I also need to tell ARKit if I want the window contrast enhanced or just stabilized. Then, I add it to the camera region provider. After adding the anchor, I call anchor updates for ID and pass the anchor ID of the new anchor. The camera feed now appears exactly at the location specified by the anchor, and my code can handle the pixel buffers provided with each update. So that's camera regions in ARKit, an incredibly useful tool for keeping track of specific areas in your environment. But before I leave the topic, there are some points I'd like you to keep in mind. The pass-through content in the camera region view, like any SwiftUI view, can be zoomed or panned using standard techniques. If you implement these transformations, ensure they are also applied to any camera frames you save or transmit remotely. It's important to understand that the enhancement algorithm dynamically adjusts its frame rate to deliver the best possible image quality. Choosing stabilization over contrast enhancement will result in a higher frame rate, as stabilization requires less processing power. And while camera regions in ARKit are powerful and allow regions of any size, it's important to be mindful of resource usage. Larger camera regions will naturally have a greater impact on memory and processing. And finally, I strongly recommend you evaluate your overall resource use as you design your experience, particularly when working with large enhanced regions. As a guideline, aim for camera region anchors to display pass-through content using about 1/6 or less of the overall visible area. So those are the topics designed to bridge your physical and digital worlds, and the last of a long list of enterprise-ready enhancements we've added this year. From making core functionality like UVC access and object tracking more flexible, to introducing window follow mode, app-protected content, and camera regions, I'm sure you'll find a myriad of ways to put these new capabilities to work in your app. And with that, let me wrap up with some final guidance. First, be mindful of environmental safety. Ensure users are in a suitable location to perform tasks safely while wearing Vision Pro, especially when interacting with real-world equipment. Remember that with enhanced access, particularly to cameras and sensors, comes increased responsibility. Be transparent with users about what data is being accessed and why. Design your applications to collect only the necessary information for the task at hand, respecting user privacy in the workplace. Ensure your application and use case meet the eligibility requirements. These are intended for proprietary in-house apps developed for your own employees or for custom B2B apps built for another business and distributed privately. And with those items confirmed, if eligible, only request the enterprise entitlements you genuinely need for your application's specific functionality. And finally, please share your feedback with us. We rely on your input not only regarding these specific APIs, but also about the future capabilities you need to build amazing enterprise applications on visionOS. Thank you for watching and have a great WWDC.